Hello, my name is Jet and my background is in science and engineer, both bachelor degree and master degree. I will teach a vector today. Vector is important in physics and math. If you find it helpful, please subscribe and like my YouTube channel and Facebook page. It will mentally support me to create physics knowledge-based content. Today, vectors, I will go over this content. Introduction to vectors, vector addition and subtraction, components of vectors, multiplying a vector by a scalar, unit vectors, scalar product, vector product. For those who need a specific topic on vector, please go ahead to this section you need. And those who completely new to vectors or who like to brush up their vectors, please follow along the topic sequence. Okay, let's get started. Many important quantities in physics have a direction associated with them and cannot be described by a single number. A simple example is the motion of an airplane. If we only know the speed of the airplane, we won't know exactly where the next location of the airplane. For example, the airplane can go to the east or the north with the same speed. To the east and the north. To put it in vector concept, v1 bar and v2 bar are vectors. The meaning of the magnitude of v1 bar equal v2 bar, meaning the size of v1 equal the size of v2, we call v bar is velocity. The speed of the airplane combined with its direction of motion constitute a quantity called a velocity. Another example is force. Push a box with a force size F and pull a box with a force size F. They are not the same force because the first box went to the east direction and the second box went to the north up or go up in direction. In vector concept, even though the magnitude of F1 bar and F2 bar are the same, but F1 bar not equal F2 bar, F bar symbol is a force. A vector quantity has both a magnitude, the how much or how big part, and a direction in space. Let me give an example for vectors. Quantity in physics, a displacement. The displacement symbol is S bar. Note, we usually put a bar on a symbol's head to identify the quantity as a vector. Let's talk about displacement. Displacement is also a vector. Displacement is a change in the position of an object. From start point, we walk. The dashed black line is called distance quantity. So what is the displacement in the picture? The endpoint? Okay, it is a vector from starting point, the tail of a vector, to the end point, the head of a vector. So this is called displacement or S bar. Example, walking 3 kilometers north from your front door doesn't get you the same place as walking 3 kilometers southeast. The same magnitude but different direction. How to represent a vector? Well, A bar is called a vector A. Magnitude of A bar equal A. Vector addition and subtraction. Let's say we have a vector A and B, then we would like to construct a vector C such that vector C equal B plus A. Draw a vector B, then draw a vector A starting from the head of the vector B. Then the resultant vector C is from the tail of vector B to the head of vector A. Okay, will the vector A plus B is also the same with vector C? Let's find out. Draw a vector A, then draw a vector B, starting from the head of the vector A. The resultant vector A plus B is also the same with vector C. Therefore, vector B plus vector A equals vector C equal vector A plus vector B. Vectors has a commutative property. For example, a cross-country skier skis 1 kilometer north and then 2 kilometers east on a horizontal snowfield. How far and in what direction is she from the starting point? 1 kilometer north, 2 kilometers east. The resultant vector is from the starting point to the end point. What is the magnitude of the resultant vector? So we can use the Pythagoras to find the distance of the resultant vector, which is square root 1 kilometer square plus 2 kilometer square, and then is 2.24 kilometer. What is the angle of the resultant vector with the north axis? Tan theta equal opposite side over adjacent side equal 2 kilometer over 1 kilometer equal 2. So theta equal the arctan 2 equal 63.4 degree. Components of vectors. Let's say we have a vector A in xy plane. How can we write a vector A in x and y components? By trigonometry, ay equal a sine theta, ax equal a cosine theta. Therefore, vector A equal ax in x direction plus ay in y direction. What is the angle of this vector from positive x-axis? Counterclockwise direction 90 degree. What is the angle of this vector from positive x-axis? For clockwise direction minus 180 degree. And lastly, what is the angle of this vector from positive x-axis? Counterclockwise direction 0 degree and as well as 360 degree. What if a vector A is in second quadrant? Ax component is in negative x direction and ay component is in positive y direction. Both magnitudes are the same. Finding a vector magnitude and direction from its components using Pythagorean theory in order to find magnitude of vector A and then to find the direction of vector A's, we can use trigonometry tan theta equal ay over ax, and the theta equal arctan ay over ax. Example, what are the x and y components of vector d, and the magnitude is 3 meter and its angle is 45 degree with plus x axis counterclockwise. So first we draw the pictures. And what is the xy components of d? So from the components vectors, y component dy equal d sine 45 degree, so it equal 3 square root 2 over 2. X component is dx equal d cosine 45, 3 square root 2 over 2. And another example, what are the x and y components of vector x bar, e bar, and the magnitude is 4.5 meter and the angle is 37 degree with plus x axis counterclockwise. So first we draw a picture. Then what is x and y components of E? Y component EY equal E sine 37 degree 2.7, and x component EX equal E cosine 37 degree 3.5. Multiplying a vector by a scalar. If we multiply a vector A bar by a scalar C, each component of the product D bar equals C A bar is the product of C and the corresponding components of A bar. So the components of D bar equals C A bar, so we have to multiply C with all the components of A. So for the example, dx equals cax and dy equals cay. Using components to calculate the vector sum of two or more vectors. Let's say we have a vector A. What is the components of vector A? Ax and ay. And then we have a vector B. What is the components of vector B? Is the bx and by. So now the resultant vector is vector A plus vector B. We can decomponents the vector R, which is ry equal ay plus by, ax equal ax plus bx. Therefore, R vector can be decomponents into the sum vector of x and y components. Example, using components to add vectors. What is the resultant vector after adding these three vectors? We will use the techniques of adding sub vectors by components vectors. So first, we reference going up is the north direction and going to the right is the east direction. We start writing vector A at the origin, and the head of vector A is the starting point of vector B. Then we draw the vector C at start from the head of vector B, and then the resultant vector is R hat R bar equal A bar plus C bar plus B bar, and Rx is the Ax plus Bx plus Cx, Ry equal Ay plus By plus Cy, and then R vector is the Rx x hat plus Ry y hat is the resultant vector. And what is the angles between r bar and x positive direction. It is 180 minus arctan 15 over 18 equal 140 degree. Unit vectors always have magnitude of 1. For example, I hat is in x plus direction with size 1. J hat is in y plus direction with size 1. What is unit vector good for? Let's say we have a vector A. We would like to write the vector A in component ax and ay. J hat is the direction and size of vector A in y direction. Ax I hat is the direction and size of vector A in x direction. For the 3D dimensions for the unit vectors, when we have x-axis, y-axis, and z-axis, the unit vectors normally represent in x direction is I hat, y-axis is j hat, and z-axis is k hat. And then when we have a resultant vector that composes of a bar plus b bar, so it will equal ax plus bx I hat direction plus ay plus by in j direction, and then plus az plus bz in k direction is equal rx I hat plus ry j hat plus rz k hat. Using unit vectors, for an example, given the two displacements d bar equal 6i plus 3j minus 1k meter and e bar equal 4i minus 5j plus 8k meter, find the magnitude of the displacement to d hat to d bar minus e bar. So we can subtract component by component. For 2 multiply 6 minus 4 in I hat direction, and 2 multiply 3 minus 5 in j direction, and then 2 multiply minus 1 minus plus 8 in the k direction. Then we get 8i plus 11j minus 10k meter, and the magnitude is the square root b square plus 11 square plus 10 square equal 16 meter. Yeah, finally we are in the last part of our vectors topics, the products of vectors. There are two types of products, the scalar product and the vector products. Okay, let's go for scalar product first. Scalar products, or oftenly people also called dot product. How can we write scalar product in a mathematical form? So on the top left, vector A dot vector B is equal to AB cosine phi, or absolute value of vector A multiplied by absolute value of vector B multiplied by cosine phi. Phi is the angle between vector A and vector B. And what is the angle between is the you place the tails, the vectors tail to tail, and geometrically representation of the scalar product is, imagine you have a vector A let me find the pointer. Imagine you have a vector A, and then you have a vector B. The A vector A dot vector B is the product of vector A multiplied by the component of vector B in the vector A direction. That's why it's A magnitude of A multiplied by B cosine phi is a component of vector B in direction of vector A. Using components to calculate the scalar product. So first, the I hat dot I hat, j hat dot j hat, k hat dot k hat. Since um, I hat dot I hat has the same direction with the same vector, so the angle between them is 0. Cosine 0 is 1, so they all is 1. And I hat dot j hat, the angle between I and j is 90 degrees, so cosine 90 degrees is 0. So then ij, ik, jk equals 0. And then now, given this knowledge, let's make a dot b in general form. So a hat a vector is ax plus ay plus az dot bx plus by plus bc. So when you branching all the components, and then we will see ij, ik, ji, jk. So all the components in the vector direction is not dot in the same vectors is go to 0. So that's why we will left only the component ax, bx, ay, by, ac, bc, since ii is equal 1, jj equal 1, and kk equal 0, equal 1. So then a hat dot b a vector dot b vector is equal ax bx plus ay by plus ac bc. So example, calculating a scalar product. Find the scalar product a dot b of the two vectors in the figure below. The magnitude of the vector are a equal 4 and b equal 5. A dot b equal AB cosine angle between A and B. A dot B equal 4 multiply 5 cosine 130 minus 53 degree equal 20 multiplied by 77 degrees. So the final solution is 4.499. Example, finding an angle between the scalar product A and B. So the definition of the dot product is a vector dot b vector equal ax plus bx plus ay by plus az bc. Then we got minus 3. And then what is the size of A? Is the square root 14. And then the size of B is square root 21. And then the definition of the dot product is a hat a bar b bar over equal ab cosine angle between ab, and the angle between ab is the arc cos a bar b bar over ab, so equal approximately minus 0.1749, and the angle between ab is about 100 degrees. Vector product. Vector product is also called cross product. Vector A cross vector B is a vector. C equal AB psi phi is the magnitude of vector A cross vector B, and the angle of phi is between 180 and 0. So cross product of vector A cross vector B is not the same with vector B cross vector A. How do we find the direction of the cross product? Using the right-hand rule to find the direction of the vector A cross vector B, place A and vector B tail to tail, like in the picture. Point fingers of right hand along a vector A with a palm facing facing B this direction, and curl the finger toward B, the thumb pointing in the direction of vector A cross vector B. So that is the direction of vector C. What is the geometric interpretation of the vector product or cross product? Imagine we have a vector A and vector B. The magnitude of vector A cross vector B is magnitude of vector A multiplied by the component of vector B perpendicular to A. So this quantity is called the magnitude of vector A cross vector B. So using components to calculate the vector product, and we learned from the unit vectors that the I hat cross I hat j hat cross j hat k hat cross k hat is equal to 0 because the angle between them is 0, and then the psi 0 is 0. But the I cross j, the angle between them is 90 degree. So when you use the right hand rule, put the uh, four fingers toward the I direction, and then wrap it around to the J direction. It ends up to be the K direction. The thumbs it end up in the K direction. And then another example, when you use you put the four fingers in the K hat direction, and then you curl it in the I direction, your thumbs is going to the J directions. So the J direction is the direction of the vector K hat cross I hat. Okay, so now let's talk about cross product in the general form. Vector C equal vector A cross vector B. So equal to AY BC minus AC BY in I component or X direction plus AC BX minus AX multiplied by BC in J direction or Y direction plus AX BY minus AY BX in the K direction, and then CX is as follow CY CC as well in the same idea. Okay, let's do some example so we will get a better understanding of the vector product. For example, calculating a vector product, vector A has these properties: A equals 6 units, and in the direction of x plus, vector B is 4 units and lie in the x-axis making 30 degree with plus x-axis, and is in xy plane. Find vector C equal A cross B. So we know that vector A is 6i and vector B is equal to 2 square root 3 I hat plus 2j. So vector C equal vector A cross vector B bar and is equal to the formula that I have given before. So you plug the values in. C bar equal 12 k hat. Hope my teaching helped you with vectors. If you like my video, please subscribe, like, and share my YouTube and Facebook page. If you have any question about vector topics, feel free to comment in box or MD me. Thank you for listening and have a wonderful day.